Hi, so in this video we're going to be looking at partial fractions and we're going to be looking at the case where we have a squared denominator. If you haven't watched the video on partial fractions for the cover-up rule, please do that because that will help you with this one. Okay, so what we're having is the case where we have a fraction like this where we have a square in the denominator, and when we split that into its component fractions, into its partial fractions, we need to have that term, the x minus 2 all squared term, but then we must also have what was in the bracket but not squared. Okay, so let's try this example. So we have this and we're going to split it with the squared term and just the term as the denominators, and we put a and b on top. Now we can use the cover-up rule to find a, but we can't use it to find b. So let's find a first. So we look at what's on the denominator of a. Here it goes. We say what value of x would make that go to 0 when x equals 2. That would go to 0. And then we put the 2 in what's left. So we cover up our x minus 2 squared, and then we put our 2 into what's left. So 2 times 2 minus 1 gives us a 3, and that's our answer for a. Now for b, we can't really use the cover-up rule, because if we covered up x minus 2, we could only create x minus 2 by expanding this, and then when we put x equals 2, because that's when this goes to 0, in our x equals 2, we would get a 0 on our denominator, and obviously that wouldn't work. So what we need to do is we multiply throughout by the squared term, and then we compare the coefficients, or equate the coefficients. So I'm going to multiply throughout by x minus 2 squared. So I multiply this one by x minus 2 squared, and that x minus 2 squared would cancel, leaving you just the 2x minus 1. Multiply this one by x minus 2 squared. Again, it cancels, just leaving you the a, and the a is 3, so I pop the 3 straight in there. And then here, when I multiply this one by x minus 2 squared, I can see that the x minus 2 2's cancel, leaving me just an x minus 2 on the top. So I expand this out. Now when after I've expanded it out, when I compare the coefficients, what that means is the numbers in front of the x terms, or the constant number on its own, they must be the same on both sides of the equation. So if I look here, I've got 2x, and for this to work, that must equal bx, and my b must equal 2. And that must also work for the constant. So you need to just go through and check you haven't done something silly. So you go 3 minus 2 times 2, which is 4. So 3 minus 4 is minus 1. And I've got minus 1 on that side, so I'm happy that that all works. So then in the end, I get that my 2x minus 1 over x minus 2 all squared equals 3 from the a over x minus 2 squared plus 2 from the b over x minus 2. And if you multiplied this out, so you had a common denominator, so you put this one on over x minus 2 squared as well, you should end up with the 2x minus 1. Okay, I hope that's helpful.